I'm Ms. Vung. Today we're going to look at the F word, factorials. Let's look at the number arrangements of these three letters. How many ways can you arrange A, B, and C? Well, you could arrange it as ABC, or you could do ACB, or BAC, BCA. What else can you do? CAB and CBA. So 6 arrangements. What happens if you have ABC and D? How many different ways could you arrange it? Well, you could do ABCD, you could do ABDC. So you could start with A and have 6 different arrangements. But let's see if we can find a pattern. You could start with B. If you started with B, then what choices do you have left? You could go A, C, or D. If you go A, you can go C next or D next. So B, A, C, what letter are we missing? D. B, A, D, what letter are we missing? C. So we only have one choice left for the 4th row. And you could do the same for the letter C and the letter D. Is there a faster way to count all these 24 choices? Well, let's have a look at the simple one and find a pattern for the more complicated one. So first of all, in the first section, we can see that we have a choice of A, B, or C. If we pick A, we have B or C to choose from. If we pick B, we have A or C to choose from. If we pick C, we have A or B to choose from. So in the second section, we have 2 choices to choose from. And in the third section, well, there's only one choice left. A, B, we can only pick C. A, C, we can only pick B, etc. So we only have one choice left for the third space. So we have this and this and this. And we know that and means multiply. So 3 times 2 times 1, it does give us 6. We found the way to work it out. So you figure out how many you can put in the first one, multiply by how many you can put in the second one, multiply by the third one. And you can visualize it using this tree diagram as well. There are, if you follow the arrows, 6 different outcomes. We can do the same for that 4 letter arrangement, but the tree diagram is going to take a while, so I've just screenshotted one there for you. So you can pick 4 things first, and then you can pick 3 things in the second space, you can pick 2 things, and then 1 thing. So 4 times 3 times 2 times 1. I wonder if you can figure it out for 5 things. How many different ways can you arrange 5 things? You would do 5 times 4 times 3 times 2 times 1, because there's 5 options first, and then once you use one option you only have 4, and once you use the second option you only have 3, etc. And you'd multiply these to get 120. Now let's say 5, we substitute 5 with the letter N. And so we can try and find a formula for this. If 5 is N, what is 4 equal to? 4 would be N minus 1. What would 3 be equal to? N minus 2. Etc, etc, until we get to 2 and 1. So this could be the general formula for 5, 4, 3, 2, 1. And we have a symbol in mathematics to represent this pattern. The symbol is N factorial, and it's represented by the exclamation mark. So this is N factorial. Factorial is a number of ways of arranging an object in a row. Let's practice using factorials. So if I have 5 factorial, that is 5 times 4 times 3 times 2 times 1. So we have 120. 4 times 5 is 20, 20 times 6, 120. You can use the calculator if you want. 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's 5,040. 2 times 3 factorial. How would you do that? So you would do it's a bracket. So you would do 2 times 3 first, you get 6. And then you do 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 720. What about 2 times 3 factorial looking like that? So the factorial is just with the 3. So it's 2 times 3 times 2 times 1. That gives me 12. What if I have 4 factorial times 3 factorial? That would be 4 times 3 times 2 times 1 times 3 times 2 times 1. And that is a big number on the calculator, and it's 144. To find the factorial symbol on a CAS calculator, click on keyboard and then go to ABC symbol, and you'll see the factorial sign there. So if I type in 7 and then the exclamation mark there, factorial, enter, I would get 5040, like we have seen in our question over here. Let's do the next bit. Example 2. Let's practice using factorials in different expressions. 5 factorial over 3 factorial, what would that become? So we know 5 factorial is 5 times 4 times 3 times 2 times 1, and 3 factorial is 3 times 2 times 1. So we can cancel out the common factors, and we have 5 times 4 equals 20. So now I can see that 5 times 4 times 3 times 2 times 1 can also be written as 5 times 4 times 3 factorial. And so I can in future just cancel out the 3 factorials that way. So for 100 factorial, I can write it as 100 times 99 factorial. And over 99 factorial means my answer is just 100. 100 factorial over 98 factorial would mean 100 times 99 times 98 factorial over 98 factorial would be 9900 or 9900. And to finish off this video, let's do some extra hard questions. So here we have 7 factorials and 6 factorials. What is the highest common factor? It is 6 factorial. So we have 6 factorial, take it away from 7 factorial, we're left with 7. Just recap, 7 times 6 factorial is 7 factorial. And then minus 6 factorial is just minus 1, because 1 times 6 factorial is 6 factorial. Now, dividing by 6 factorial, we can cancel out the common factors, and we're left with 7 minus 1, which is 6. 10 factorials and 8 factorials, what is the highest common factor? It would be 8 factorial. So taking the 8 factorial out of the 10 factorial, we're left with 10 and 9. And then over 8 factorial, cancel the common factors out. 10 times 9 is 90, plus 1 is 91. This one looks scary, but it's not once you try and do what you can. So here we have 5 plus 3. Highest common factor is 3 factorial. So now we're left with, from the 5, we're left with 5 times 4. And from the 3, we just have the 1 over there. And the highest common factor between 4 and 5 is the 4 factorial. So now we have the 4 factorial times 1 is 4 factorial. 4 factorial times 5 is 5 factorial. I'm just checking. Now we can cancel out with tops and bottoms. We have 3 factorials that we can cancel out, and the 4 factorial we can cancel out. Now we're left with 5 times 4 is 20, plus 1 is 21, and 1 minus 5 is minus 4. So minus 21 over 4. The n factorial is n times n minus 1 times n minus 2, etc. times 2 times 1. And we notice that n minus 1 factorial is equal to n minus 1 times n minus 2 times n minus 3, etc. 2 times 1. Or in other words, it is this section over here. So if it's that section over there, we can rewrite this line here, n factorial times n times all of that as n minus 1 factorial. And we can rearrange this n minus 1, so the opposite, the inverse of times is divide. So now we have n factorial over n minus 1 factorial equals to n. And we do so because if we let n equals 1, let's see what happens. The right side is equal to 1, the left side is 1 factorial over 1 minus 1 factorial. 1 minus 1 factorial is 0 factorial. Now how is this statement true? This statement would be true, 1 factorial is 1, is equal to 1 if the 0 factorial is also equal to 1. So 0 factorial must equal to 1. If 0 factorial was equal to 0, this last line wouldn't make sense. So don't forget that 0 factorial equals to 1. Thank you for watching. I'll see you next time. Bye!